Hello everyone. Let us see one more question as like a problem number 7 our series of JE kinematics problems. This is about a particle projected horizontally from the rim of a large hemispherical bowl as shown here. See, this is a bowl assumed to be placed on the horizontal platform, and they said horizontal direction as x-axis, vertical downward direction as y-axis, and they projected a particle from here with u speed. Okay, and before going to continue with the question, let me explain you the possibilities first. See, as it is like projected from certain height, it may follow its own projectile path and may land somewhere here as one of the possibility, or even it may land somewhere here as one of the possibility. If you observe the vertical downward direction from the center of the ball, spherical ball, it will exactly meet the lowest position of the ball, or this projected ball may even landed exactly at the bottom of the bowl. Okay, I mean here I am going to take the three possibilities. It may land or it may hit the ball anywhere else in this zone, as possibility 1, or exactly at the bottom of the ball as possibility 2, or else somewhere else in this zone as a possibility 3. Now let us see the next continuation of the question. The displacement of the particle when it strikes the ball for the first time is to be as capital R. That is what the condition they have mentioned here. Okay, displacement of the particle must be capital R. If this is the case, you need to find velocity of the particle at the instant of hitting the ball, as well as how much time does it take to hit the ball at a suffering of r amount of displacement. Okay, and these are the answers which you need to prove here: velocity while hitting the ground, time to hit the ball at that spot. Okay, see now first here, let me zoom out the figure a little bit here. Among these possibilities, first let me check why not be second one. If it hits, what happens if it hits exactly at the base of the ball? Let us consider as one of the possibility. Suppose, let me erase it and let us go for more clear diagram. This is the base of the ball or the platform, and if the projectile landed exactly to this particular place, we know this line length will be equivalent to capital R. This is also will be equivalent to capital R. And you know the displacement definition wise, the shortest distance between initial and final points. So this line length, actually the displacement should be capital R according to the condition, but according to the figure, what one can notice here is that by means of Pythagoras theorem, it ends as root 2r, which means our assumption of this is going to be hit point is proved as wrong. Okay, it is a wrong assumed position. See, for this position itself, if you got displacement root 2r, then imagine for anywhere else in this zone, I mean if it lands somewhere else here in this way, obviously the displacement is going to be more than root 2r, right? I mean more than r. It would be even more than root 2r also. But you are supposed to get displacement as r. Hence, the projectile is concluded now is going to land somewhere else within this left zone, and we are going to make our analysis taking that as a correct approach. And let me go with our solution and mathematical work with a new figure. See, it is the hemispherical ball, and you projected a particle here with horizontally with u speed, and it is going to be assumed to be landed somewhere else here following the parabolic path. This is the spot where it hits the ball. Let me draw one line through that hit spot, which is going to be my reference line or reference plane. And now if you take, this is the center of the ball, if you drop a line up to touching this blue color dotted line, okay, see, up to here it will be capital R, but up to here it will be less than capital R. Let me find out that one, because it has its own importance in our analysis. Now if you make a line from here to here, which we call as a displacement, it is, if it is capital R, as we know that this is also anyhow will be equivalent to capital R, and if you join a line from this spot to hitting spot to the center of the sphere, hemisphere, it is also be capital R. Now one can see a clear structure of right angle equilateral triangle. As it is an equilateral triangle shape, it will be 60 degree. Here also you can get 60 degree. Here also you can get 60 degree. Meanwhile, I can notice this is going to be 30 degree. Okay. Suppose this is spot, say it as a D. Now, say this is P. From OPD right angle triangle, one can notice that this value will be R cos 30, as it is cos 30 is root 3 by 2. You got now OD line length as root 3 R by 2. Right? Now here, if you imagine a line parallel to this OD line, it is also equivalent to root 3 R by 2. And say, or feel as if this is like a one tower height. It is a ground, which one, this is the ground, this is the ground, and you need to imagine a plane little bit more, little bit higher over the ground, and this is going to be our landing plane. This projectile is now like a clearly horizontally projected particle from certain height. And you know, velocity of a projectile obviously will be written as Vxi cap plus Vyj cap, because it's a 2D motion, no? Two components will be there. See, while hitting the ball at the hit spot, your horizontal velocity will be, as it is continued like initial one, that's a well-known fact. And vertical velocity will be given as root of 2gh. From our basic knowledge, everyone knows this. So V bar will be Ui cap plus Vy will be root of 2gh j cap. So V bar equal to Ui cap plus root of 2g, h value what just now we got as root 3 R by 2. You can substitute over there, and obviously 2 to get cancelled here, and you end up the answer of velocity at the instant where it hits, having suffering R amount of displacement, is now clear that root of root 3 gr j cap. Okay, this is going to be our first answer regarding velocity, right? And now continue to second part, as you want time of flight or time taken to hit the ball from projected point onwards to hit spot. So as it's like a time of flight, whose formula, which is a famous formula, we know root of 2h by g. So in this place, root of 2 by g and h value is root 3 R by 2. I got the answer of capital T as root 3 R by g, which is completely under root again. Okay, so this way I can get the solution, and you can compare the which is already written as a solution, I mean answers here, to the values which we got now here. Okay, thank you.